The broadcast is now starting. All attendees are in listen-only mode.
To the Edureka classes. And today's topic which we are going to cover is the linear regression. So let me know first of all, am I audible to you guys? Can someone write? Am I audible? Yes, great. So we can go ahead. Okay, so before starting the things, we are going to talk about some of the basics. Even though some of people might know about these things or might have attended earlier lectures in which we had little bit discussion about them. So let's talk about what is an algorithm. So algorithm is the way to tell your computer that what it has to do, right? So you have some steps, you have some problem in your hand which you want to solve, and the problem need to be solved by, in reality, by the computer. But you will tell the computer that what are the steps which it needs to carry out so that your problem can be solved. And that is what you do through by writing a program. And program through the program, you are telling what is exactly the algorithm is, right? Or we can say program is nothing but the logic, right? So logic, how the problem should be solved. This should the first step, this should be the next step, and so on further. So these things are your logic, which you are defining using some kind of language syntax. So you might be using Java, maybe Python or JavaScript, right? So any programming language you might be using to tell your computer exactly what it should do, right? And that's two in the form of the steps. So that should be the first step and second step and so on. Okay, so let's talk about a process or set of rules to be followed in calculation or other problem solving operations, especially by a computer, right? So this is what we have told. Exactly, you are telling what to do when at particular time, right? So let's say you want to write an algorithm which will print the numbers from 1 to 20. So how you are going to do this thing in a simple way? Let's say I'm using first one variable which we are allocating value 0, right? So after allocating value to 0, then you increment the value of x by 1. So after that, so what become x value is 1. And once it becomes 1, what you are doing here, you are printing the value of x. So it will print the 1. Then you check the condition, is x is still less than 20, right? If it is less than 20, then you will go here, right? Or if it is not, then towards the no you will come, and here your program will end. But when it is 1, it means still it is less than 20. So this condition would be true. You go again back to this loop where again you are saying increment the value of x by 1. So the latest value was 1. When you increment it by 1, it becomes 2. Then you print the 2, right? And again you do this check condition. So you keep doing again and again this same thing until you reach to the final point where you have printed all the numbers till 20, right? So this is an algorithm. All these, this is the rules you are telling to the computer, so that computer will follow these rules and do the work on your behalf. So let's talk about what is machine learning. So machine learning is so there are two questions might be here. First of all, yeah, definitely we are going to see what is machine learning. Secondly, is the machine learning algorithm is exactly the same kind of the algorithms which we have been talking till now, or is it something different compared to that? So if we talk about the definition of machine learning, then it is a type of artificial intelligence that provides computers with the ability to learn without being explicitly programmed. So here we are bringing one term that it is giving the ability to learn, right? So it is giving ability to learn to the computer itself. So computer will learn automatically on its own. We doesn't need to program it explicitly, right? So what does it mean, programming explicitly? Like if I am writing a program where I am telling each and every step to the computer that it should do now this thing, then this thing, then this thing, then this is equivalent to programming explicitly. But if you are not telling it, but you are giving the ability to computer to take on its own decisions, right? So after that, you don't tell exactly how to print the number from 1 to 20, but you just tell print the number 1 to 20, but it has automatically learned how it can do this step, right? So learning this thing, that so that you doesn't need to explicitly give the steps to the computer to do the or to carry out some kind of task, right? That becomes your machine learning. So we are giving the ability of learning, right? So like human being, if I talk about this particular, if I talk about for printing or let's say writing the number from 1 to 20 to somebody, once I teach you this thing, then you learn it, right? And it is not only one thing you learn, but many things you learn. And then I doesn't need to tell explicitly that what to do at which particular case. Then whenever any such situation arises, you automatically take your steps, right? So the same thing we are going to do here when it comes to machine learning. So there are different types of machine learning techniques are there. One is like supervised learning, reinforcement learning, unsupervised learning, right? So we had little bit introduction to them day before yesterday. So quickly we will go again here. So supervised learning are those kind of algorithm where you are supervising the training, right? So in reality, what do you mean by even you are? Is that you are not only giving the problems, right? So it is equivalent. Let's say I want to teach you mathematics, right? And I bring, let's say, a book. I took a book, and in the books there are, let's say, 100 questions are there in my book. So out of these 100 questions, what I might do is I take the 70 questions, I show you those 70 questions, and while showing those 70 questions, I show you their answers as well to you, right? So what I'm doing here is I'm not only showing you the question, but I'm showing the solution to that. So it means this is supervised learning because I'm telling you how to solve the problem, right? Or what is the solution for each of these problems. So this kind of technique becomes supervised learning because we are supervising this thing, right? So you learn now these using these 70 example under supervision or by looking at the solution of these, and then for the next 30 question might be conducted as a test for you where they will be knowing exactly that how good a particular person has learned, right? So the way we check with the human being by conducting the test, similarly we do with the our machine learning technique. First we give them the problem, we give them the solution, then it's the duty of the machine learning algorithm that it find out what is the relationship between the input and output, or we can say problem and the solution, so that we are not telling it exactly that how it can reach to the solution, but we are giving the problem, we are telling what is the solution for that, and automatically machine learning techniques start learning from by looking those problem and solution on its own. And later on you conduct the test, give 70 questions, and it will 70 questions you teach, then maybe 30 questions you keep in secret with yourself, and then you do not show the answer to those 30 questions to the algorithm. You just give what is the questions, and then it will give you the solution. And when it comes to unsupervised learning, nobody is giving you the solution, right? Nobody tells you. So for example, let's say if I want you to learn, let's say from images, right? So if I give you images for, let's say it is a fruits image. So if I give you the fruits image and I tell you also that which fruit image it is, right? This is apple, this is mango, this is banana. So this is a supervised learning because I'm not giving you only the images, but I'm giving you the solution. What is the name of these images? In unsupervised learning, we do not show the solution, right? We just give you the images, and from the images you have to learn, right? So automatically. So this is where it comes the unsupervised learning. It's mostly is like work is of the clustering actually, or grouping, so that you by looking the images you can group the similar images together, right? So this kind of techniques where nobody is supervising the things, we call it as a unsupervised learning. Next is the reinforcement learning. This uses the psychology of human being, right, or the child behavior, the way a child learns from his or her parents, right? So whenever child is doing something good, the parents of the child appreciate the child, and because of which child understand, okay, in this particular situation, this is the action which I need to carry out, right? And similarly, whenever child is doing something wrong, you might become angry, or you might say do not do this thing or whatever, right? But you are telling somehow, or it's true, the child is able to make from the context that in this particular context he should not take this particular action. So same with the reinforcement learning, and it is about teaching the skills to the computer, right? So there are like skills we might want to teach our computer how to drive the car, right? Nowadays driverless car are there in which computer is operating, no driver, computer itself take the action. So this is a skill, right? So similarly, we have other things nowadays. Even I think I told you guys earlier as well that there had been a system had been made which is a music system, right? That is music production actually system, that you doesn't need to do anything, and this particular AI based system can generate the music as any human being generates, and that's not something completely random, but very melodious and properly with taking care of all the rules of the music or notes or whatever those are. So there reinforcement learning used. Or if you want to make a system which can learn, let's say chess, you want the computer to be a very good at chess, then you use reinforcement learning. And I don't know if you guys are aware about this one game. I think its name is Play Go. Probably it's a Chinese game, or I think AlphaGo is the game, or Play Go. I don't remember exactly the name. So this game was taught by this game was learned by the computer first by using the reinforcement learning, where it takes action again and again. It is learning by like human being only, where it plays again and again. So it played many time against itself. Computer played against itself this particular game and was learning the strategies as it was playing, right? By looking at the what uh, good thing score it is getting or bad score is it is getting by taking a particular action. And after that, after it is being trained, then they conduct a competition against a world champion of this game, and has beaten that particular champion in the game, right? So you can see how powerful this reinforcement learning is. So let's see how a problem is solved using a machine learning. So some of you, the older one who have seen the first class might have seen already this slide. Here we say there are different kind of techniques are there, right? So the top three techniques like classification, anomaly, and regression, they all are the supervised technique only. This clustering while is the unsupervised, and reinforcement already you know it's itself a whole algorithm. So what is when it comes to supervised learning, we are saying we are not providing only the input to the computer, but we are providing the output values also to the computer, right? So like images, we are not giving only images, but we are telling also that what would be the output of what is the name of those images, so that it start learning, right? So now we call their output values the kind of, let's say we are talking about fruits images, right? So 5 fruits images might be there, right? So Jagri Akhil is saying hello. Yeah, hello Jagri. Is there any question you want to ask? So whenever anyone I want to ask question, feel free to write your query. Okay, so we have been discussing about the so we were discussing about the classification technique, right? Or classes, right? So output values are given. Now, what kind of output values these are? That is what is defining the type. Let's say if the number of output values our problem has is limited, right? So let's say if we want to detect whether a person has cancer or not. So there are only two output classes, whether a person will have cancer or he will not have. So that become a classification algorithm. Anomaly is something where the thing is out of group completely, right? So we say that anomaly, like, is this weird something, right? So for example, if we are doing, let's say a lot of transactions are being done in the bank, and we are looking that is there any transaction which is fraud in my system. If there is any transaction which is fraud in my system, it is far away from the normal transaction or most of the transactions. So such kind of issues where we are finding something which is not following the general pattern, we call this thing as an anomaly detection algorithm. Regression, where we start having unlimited classes, we can say, right? So for example, if I'm talking about the temperature could be anything. It might be 20 degrees Celsius, 25 degrees, 20.1, 20.11, depending on how accurately or how precise our temperature sensors can give, right? But yeah, this is, we can say, infinite values can be given by regression algorithm. Clustering algorithm, how you are organizing something, right? So like for example, grouping of the things. I took example earlier as well, that is of the articles, right? So let's say if you have created a website on which you allow anybody to post the articles, and these articles may depend to any category. So people are just randomly posting the article and they belong to different categories, but they are not telling that to which category these particular article belongs, right? So Bharat is asking how we will check students' question, what they are asking. See, whoever write the question, it comes to me and I can read the question for all of you guys. So there is no problem. Whenever anyone has a question, you just ask your question here. I will be knowing and I will be reading it for all of you guys. And then definitely I will be discussing the solution as well for the question. Okay. So we were discussing about the clustering algorithm. We say that there are lots of articles has been posted on your website, right? And but these were not organized, nobody take care of what to decide what category it is, right? But now as it becomes many and many, it becomes pretty difficult for you to organize your website, right? Because people come and then you cannot give what they you cannot recommend them properly. So what do you start thinking? If I can organize them into a proper categories or maybe in a groups, then I can give good recommendation to the people as well. So like for example, let's say you just apply the clustering algorithm, and because of this clustering algorithm, the groups were made in such a way that the articles which look similar would be grouped into a one group. The articles which look different, they would be grouped in a different groups, right? So now whenever somebody is reading one news from one article, then you can suggest some belonging to the same group, right? So Jagri actually is asking a question. I will take because this is like not related to currently this slides and all. So you are asking what is the best certification for data science. We will be discussing about it, and you just remind me, right? Let's focus currently here in the topic. And then we have the reinforcement learning, as I told already to you guys about the reinforcement learning, right? So it is about teaching the skills to the computer. So here, so like classification algorithm they are giving, is it like whether it would be like probably like where we have the limited number of classes, like we want to know is it cold or not. So yes or no we can say. Will you go to work today? Yes, no, or maybe, right? So three output values can be there. So whenever we have the limited output values that can be taken, then we call them as a classification problem. So where we have the two choices, we call it as a two-class classification or binary classification. And whenever we have more than two choices in the output classes, we call it as a multi-class classification. Here anomaly detection. So if you see all these people, right? So all them looks alike, right? But just this person is different, right? So this become anomaly because this is not following the pattern what is followed by most of the data points, right? So anomaly detection is if something is weird, right? Something is not as generalized or common way. So regression algorithms are used to calculate the numeric values mostly, because if we talk about the infinite values, then it will happen with the numeric values only, right? So for example, what will be the temperature tomorrow, or how much discount can you give on a particular item, right? So wherever the numeric values are there, and it can be anything, right? Real values specifically, if we say real values, then it becomes infinitely, right? So we use their regression algorithms technique, right? So if you see here, like in classification, you can see here two categories in this question, only two output values in this particular problem statement. There can be only three output values, but if we talk about the temperature, there it can be anything, right? 25, 26, or 26.1, 26.2. Infinite possibilities are there. And as we talk about the clustering, it is about grouping the similar items together, right? By looking into the data. So it looks into the data and find out which are the similar items and group them together. So it helps in organizing, right? So this is what clustering do. And reinforcement learning, as I told you already, this is basically more like giving the skills to the computer, like a system which plays chess, right? A temperature control system when it has to decide whether temperature should be increased or decreased, right? So like if you sit here, if you sit in your room and when you feel is it cold, then you start thinking, okay, I should reduce it little bit or I should increase it, right? So giving the decision powers here, and that work completely on the punishment and reward system, right? So it is more like doing the step again and again. So learning by doing, we can say this thing for reinforcement, right? So for example, if you're talking about the driving car, so if it is taking correct turn, then you give the reward. If it is taking wrong turn, then you punish it, right? So there is a mathematical way which is defined to give the punishment and reward. It is not like every time human being will come and say, okay, this is punishment for you, this is reward for you, right? But we need to define some function mathematical which would be enough to take care of all the cases for punishing or rewarding. So we can divide our algorithms, like machine learning algorithms, divided into three parts: supervised, unsupervised, reinforcement. So there are many different kind of techniques are there. So like in supervised, we might have regression techniques. So regression is like linear regression, polynomial regression is there. And then we have the classification technique. So these decision tree and random forest, they are actually coming in both cases. It is being used for the regression purpose as well as for the classification purpose, right? So you can use for both of them. And these further algorithms, these mostly are classification, KNN, trees, logistic regression, naive Bayes, SVM. But some of them again can be used for the regression as well, like KNN can be used. Trees, actually, this is talking about these trees only. And logistic regression you can't use for the regression. Naive Bayes again you can use, SVM again you can use, right? So many of the algorithm you will find which can work for the regression as well as for the uh, classification as well. When it comes to unsupervised learning, we have the clustering technique. Clustering technique is about like how do we cluster the items together. So there are different techniques are there, like SVD is there, PCA algorithm is there, which is principal component analysis. Then K means clustering is there, C means clustering is there, or we call it as soft clustering. And there is one more hierarchical clustering is there, which is very important, which you guys would be studying throughout this course. And there are some cases which are also unsupervised, and we call them, it comes under the recommendation system. So association analysis, there are two algorithms for association analysis, which is a priori and FP growth. So what purpose association analysis is being used? It is like if you go to the shopping malls, right? So then you will find the discounts, the way they are keeping the items together in the shopping mall, they have a particular way. It is not like they just put the items randomly anywhere, right? But they choose those items very nicely so that items will be put in such a way so that their sale can be increased, right? Let's say you go to the shopping mall to buy the bread, right? And you didn't think to buy the butter, or it didn't come to your mind that I should buy the butter. But when you are buying a bread, next to the bread you are seeing is the butter, and then suddenly you get the taste of butter also, and you think to buy this butter also I need, right? Otherwise you might not buy the butter and go back just buying the bread. So they are finding that which items are associated with each other or which can be sold together, right? And then that is what helping them in putting them to increase their sales, right? And not only this thing, that is how on the basis of they are bringing the offer that you buy this thing, get this thing, or combo offer, that much percent discount, right? They look exactly what can increase their sale or the profit, and only then they take the decision. So this is what we call as the association analysis. So this is what happened in the shopping malls. We have one thing here is not written actually, that is recommendation engines, right? So you guys would be learning also recommendation engines, how you can make a recommendation engine. So what is the difference between recommendation and association analysis? Association analysis is doing in the mostly in the physical stores, right, or physical shopping malls, while recommendation engine is being used for for online shopping cart like Amazon, Flipkart, such kind of things, places, right? That is where recommendation system is used. So why a different kind of algorithm compared to association? Why we cannot use these? Because recommendation we have more freedom, right? We can give different recommendation to different user, right? By looking exactly the requirement of each user, because for each user we can design a specific or a particular web page can be designed on the basis of user requirement, right? So you might see that for one user, the, let's say if you are watching a song on YouTube, and you are watching a particular song, and the same song is being watched by your friend, and the chances are there also that the next song which is coming into both of your recommendation might be different as well, right? So this is something very important. So Kadri is asking, can you show us practical, please? Yeah, for them we will be doing one by one. Today we will be seeing linear regression practical, right? And as the further classes will be going on, you will see other practicals. Then we will be having hidden Markov model as well. And then we have the reinforcement learning, which I already told about, right? And hidden Markov model, you can think when it depends on the state, right? If something this is happening, then another thing will happening. And when this thing happens, some other thing happens. When there is a chain of rules that where we use the hidden Markov model, or actually there is a states diagram. So we will be just keeping it. I will not talk much about here because in a small time it's not possible to discuss it. So we will have the demo related to linear regression in this class, but let's study about the linear regression first of all. What is linear regression, right? So regression, you guys might have understood, where we are saying the output values might be, output values could be infinite, right? So it can take infinite values, right? Possibilities are infinite. What is the correct value would be one only, right? So tomorrow, what would be the temperature is only one, that is maybe I am talking about, let's say, particular time period. Like what would be the temperature at 11 a.m. tomorrow? There would be only whether it would be 28 or 27 degrees Celsius. Let's say only one value is possible, right? But if I see here, what is the possibilities? So infinite possibilities, I can say it might be 20 degree, 20.1, 20.2, and so on, right? So what linear regression is exactly is it is a method to predict dependent variable y. So what is dependent variable y? We are calling as a output variable, or in this case we can say temperature, let's say, based on values of independent variable x, right? So some values are given like x on which we can say that y is dependent, right? So that is we call as a input variable actually, or input values are there. Let's say what whether today, what is the today's humidity and what is today's wind temperature. On this depends what would be the tomorrow temperature, right? So in this case, dependent variable y would be temperature, and today's humidity and wind speed would be my independent variable, or we say x, or we can say it as a input variable. So let's see. So we have classification and regression capability. So we'll see quickly. We will go rather than discussing this thing. We will see where is linear regression used, right? So we will just make it short way so that we can do the practicals as well. So where it can be used for evaluating trends and sales estimations, analyzing the impact of price changes, assessment of risk in financial services and insurance domain, right? So these are the few places where it can be used, right? So wherever output value is going to be anything infinitely possibilities, we can use the linear regression. So let's understand linear regression. How does it do actually? So linear regression, if you have to think, let's say if I'm talking about there is a one input variable, or let's say one independent variable, that is x, right? And the one output variable, let's say this is a y, that is our output variable, right? So input variable x, output variable y. Let's say x is my today's humidity, y would be my tomorrow's temperature, right? So this is, so we are keeping it very simple by saying one input variable, because for visualizing it would be easier for you guys, right? So you might be looking for the past. In the past, what happened? Let's say when this was the input variable value, right? So I will just take this thing. When this was the input variable, that is x value, then y value was that in the past case, right? So when the x value, let's say 23, humidity, then the temperature was, let's say, 27 degrees Celsius, right? So this become a point. So if I have to define this point into this two dimension, then I will be saying at this intersection it becomes a point, right? Or one data point is there, I can say this is as a data point, right? And this is a line we, even though we are drawing, but how this line should be drawn is, again, you can think the another data point is here, right? So for example, x is 0 when, let's say, humidity is 0, then the temperature is this value, whatever, right? So then if you join these 2 points via a straight line, then you get this straight line using which you can do the prediction further in the future, right? So linear regression is all about finding that straight line, right? Linear means linear, right? So the line, simple line. If we are talking about the plane, it might be, but the plane would be again linear, depending on how many input variables are there, right? We are not saying it would be polynomial, but we are saying it would be linear, right? So here, for example, here from here, if we switch, let's say, if I increase this value and it becomes, let's say, y this way, right? So it increases from here to here. As I increase from here to here, this increases from here to here. They're showing that if you are changing different value of x, y value is changing, right? So it is showing how when you changing the x value or input variable value, how the output variable is changing, that is y. And then when you try to find out, all the changes can be shown by this particular line, right? So whatever earlier changes we saw, those can be seen by this thing. So here we are saying it is a positive relationship. What do we mean by positive relationship? As I am increasing the value of x, y value is also increasing, right? So we call this thing as a positive relationship, right? So here, if we increase this value, let's say, and this value decreases, in this case, what would be happening? Then we will say it is a negative relationship actually. So it will go into the reverse direction. So you might have seen earlier how the line was going. In one cases, line was going upside, while there was a positive one, and in the other cases, line was going downside, which we say as the negative one. So drawing these line is known as the linear regression, right? So we will be getting the observation. Observation is nothing but the data point. Let's say for past 1 month you collected your data set, right? Where it showed that if this much is humidity, that much would be my temperature, right? So let's say this is a one observation or one data point. Let's say it was of, let's say 20th of September data point. It was that when the humidity was here, then the temperature was here, right? So this is one observation point you say, and let's say this is another data observation point. So as you see, this is showing when the humidity was this much, then temperature becomes this much, right? So what do you start doing is you basically start taking all the observation, right? So let's say this is a data point. These all circles are defining a data point, right? Then you try to find out a line which can go through these data points, but you will see it is not possible to find any line which can go through these all data points. So what you will do, you will try to find such a line which can go through maximum data point. Or if you find out the how much away these data points are from the line, it should not be much far away from the line, right? As close as possible data points to the line, it would be good, right? So we call that the error should be less, or the error method which we will be using is the least square method actually, right? So let's say this is the estimated value, right? Let's say, so what we are showing here, in reality this data point is existing here, right? So when the x value is this, in reality for this data point y value is this much, right? But if you are going to use this line to estimate this value for this output, so what you will, so if somebody say, okay, this is my x value, then because you are using this line to predict this value, according to this line, when x value is this, then y value is going to be this much, right? Or here it will be showing. So how much error it would be, that much error is there into your data point, right? So this is what we are going to see here, right? So you see here that much error we have into us. Similarly for this data point, that much error. So for each data point we calculate basically error, right? So for this, for this, for this, so for this it would be 0, for all we find, right? So here it is very less. So we will try to find such a line which can minimize the error, right? So we can have many lines, right? You might say, why not this particular line, or why not this particular line, right? Many lines are possible, but you will see the one which we are looking is which can minimize the error, right? So we need to find out the way which can minimize the error, right? So here they are showing, we can think that it might be anything, right? So like it might be speed or distance, It's just showing the relationship for the equation, let's say. So what would be the line equation? Line equation is always, if we are talking about one dimension, y is equal to mx plus c. If we are talking about two dimension, it becomes y is equal to, if we are talking about three dimension, where we have, let's say, two x values, right, or two input variables and one output variable. In this case, we will have y is equal to m1x1 plus m2x2 plus c, right? So this is a plain equation, we will say, but this is line equation. We are getting only one input variable and one output variable. So here this is y-intercept, right? So what is this C is defining? What is the y-intercept, right? And what is this? What is y-intercept? You guys might be knowing already these things from your 10th class mathematics, if you remember, right? That in equation y is equal to mx plus c, c basically tells where this line is cutting or intersecting the y value, right? So if we have this kind of line, then we will say negative relationship, because as we are increasing the value of x, the y value is decreasing. So we call it as a negative relationship, right? And here, when we have such equation, in reality, slope value would be negative actually, right? So if you take m as a positive always, then this negative would be there, right? Depending how you take the m. So m defines the slopes, right? So in the earlier case also it was defining the slope, right? So here, but if in this case slope value is positive, right, it is increasing because, but while if you see in this case, slope value will find as a negative value, right? But you doesn't need to write two different equations as such. You can write y is equal to mx plus c directly, where m can take negative or positive value, right? So this is the way things are. So y is nothing but the dependent variable, right, which is our temperature. X is nothing but our independent variable. Let's say this is our humidity, right? And c is intercept. So for finding this, so data points is given. So in reality, what we need to find is what is the value of m and c, right? Somebody will give us x value and we will be predicting what is the y value if m and c value is given, right? So if we can calculate now m and c, and then whenever x value will be given to us, we can do the prediction here. So let's understand the linear regression. Let's say these are the x values are given to us, or input variable values are given to us, and corresponding to them, these y output values has been given to us, right? So we can draw each of these data point, right? So we are taking first data point, which is 1 3. So if you draw here, 1 is here on x-axis, 3 here on the y-axis. So this become our data point here, right? So here it becomes our, this is our data point, right? So normally we got one data point, 1 3 would be here. Similarly, we will put all the other data points as well, right? So 1 3 comes here, and similarly when we draw all the other data points, so like 2 4 we get here, right? X value is 2, y value is 4. Similarly we get the 3 2 next, which is coming here. Then we get next 4 4 coming here, then next 5 5 coming here, right? So these are the data points, right? So this is the data point has been given, right? So this is the input values that has been given for the from the past, and what was the corresponding y values given from the past. So what we want to do is we basically find out a line which can go through this. So Qadri Hassan is saying it looks like variable chat. Variable chat means are you doing it on the fun part or like what? Or you have a query here? Okay, so if we're doing okay in physics, okay. In physics, yeah, it might happen like this. I don't know about this thing. Physics, I'm not from the physics background. Okay, great. So we will be finding the mean, right? So on the x-axis we will find the mean, which is 3, right? So what we want now actually in reality, we want to find out such a line which can be closer to all of these data points as much as possible, so that the error can be reduced, right? So which we are talking about. So first of all, what we will do, we will find out the x mean. So here x mean we are getting as a 3, Then we find out the y mean. Y mean, if we take it, we will get the 3.6, right? And then we get this point. So we will say our line might be going through this particular this point, that is 3 3, right? So but here how this exactly line will go, that we have to see, right? So here it would be definitely, it would be going somewhere from here, right? So we call this point as a 3.6. Then we have to calculate the value of m, right? So one thing, we just got the x and y bar. So how we can calculate the y m value? So we need to calculate the m and c value. X and y has been given to us, right? So normally we can, if these all are falling exactly onto this line, then we can just take two variables, two unknown, right? So two data point we can take, so it becomes two equations and two unknowns. But here these are little bit away from each other patterns, so we need to find a common ground, which we'll be doing it using the mean. So how this m would be calculated is this way: summation of x minus x bar multiply y minus y bar divided by summation of x minus x bar. So there is a whole mathematic behind it actually. So if anybody is interested in a short quick way, I can tell you. If you are good with the mathematics, you might understand it quickly. That you basically just think this is an equation, right, where you keep the m and c, and for each of these x-axis value you put them, right, and these are the corresponding y value, and then you take the summation over them, that is error, right? How much it is deviating from this, you take it as an error and then differentiate it, right, with respect to x. And when you differentiate it, so it will give you minimum error value. That's what you are looking for. But as to keep it simple, currently you can just remember that for finding out the m, this is a formula, and this is what we guys would be doing. So we know the mean for x and y, that is 3 and 3.6. So we need to calculate the x minus x bar here. So we do it quickly. 1 minus 3 becomes 2 minus 2, and so on. We do it for all the values, right? So this way we get all these values in such a way, right? So we got x minus x bar, right? And now we want to take the y minus y bar. Similarly, we calculate. So we know the y here. We have the y bar 3.6. So we remove, delete it. So this becomes, so there is like little bit editing mistake here, right? But I hope so you understood completely. You got y minus y bar. Then you calculate x minus x bar whole square. So you will be taking square of all these values, right? So you get the square. Okay, then here we have to multiply both of them, right, before taking summation. So we multiply them. This is the table we got, and we take summation over that. So this is 10 and this is 4, right? So 10 we get in the denominator, 4 we get in the numerator. So we get here 4 by 10. That's make it m value as a 0.4, right? So we get m value as 0.4. So here, just quickly, I will take you guys. Oh, this is repeating the same thing only. It's stuck here somewhere. Okay, webinar registrant is asking, I didn't understand the x minus x bar square. Actually, this is not x minus x. This is x minus x bar. So x bar is the mean of the x, right? So x value is this, let's say 1, and x bar is this 3, which is mean here, right? So it is equivalent that I am subtracting from 1 minus 3, right? So that becomes here this one minus 2, right? Then I subtract for the next two, I take 2 minus 3, then it becomes minus 1, right? 3 minus 3, it becomes 0. Is it clear now? Yes, thanks. Yeah, great. Okay, so we got this thing. Now we will talk about the mean square error, right? So this way we get the value of m, right? So we get the value of m, and then here, one second. Okay, so we got the value of m. Here they have written c value as well. Actually, we missed the c values. Okay, and what is the formula for what is the formula? So we got m value, right, which is zero point 0.4. And what is the formula for y? Y is equal to mx plus c, right? So we get the mean of y is 3.6. We got the m value just now 0.4. We know the x bar, if we are talking about mean, is 3, right? So we use this, we put all these value here and we get the c value, right? So we put the m value as 0.4, which we calculate. We put the x value as 3, which is mean of the x. Similarly, we can put the y mean, which is 3.6, and then we get the c value this way by putting all these values. That is, we get here. There seems to be some question I will be taking in a second. That makes c is equal to 2.4, right? So we get the equation. So Jagri Akhil is asking, can you share this PPT with us, sir? I am not authorized to share it, but I think you might have the support number of the support contact number or maybe email ID of the Edureka, so you can request them. They probably will share it with you, right? So I don't have any medium to share here as well. They can share it with you. So they are the authorized person to share it with you. Okay, so let's talk about the mean square error, right? So we need to calculate the error, right? So for that, we can use different measures are there. So one measure which we are finding is mean square error. So by plugging different values for x into the equation, right? So by plugging different values of x into this equation which we have calculated, we can find out the corresponding y values that are on the line drawn, right? So we are predicting some values and in reality there are some values, right? And many times it might be possible the value which we are predicting might not be the correct one, right? So it might be somewhat deviated. So how much it is deviated from the correct value, right? So let's say if the correct value should be 28 degrees Celsius for tomorrow's temperature, and we are predicting as a 27.5 degrees Celsius for tomorrow temperature. So it means there is a zero point 0.5 error, or we can call this as a residuals, how much we are not predicting it correctly. Okay, so the least square principle says what we are looking for, that we want to find out the best line, right? So best line where this error, if I add all these errors together, right, and then its sum should be minimum, right? So that is what is we are going to do. And when we say least square principle, we are basically talking about that particular line which gives us error, and we take basically some of those error, right? And some of those errors should be as minimum as possible. So here in this case, if we calculate the mean squared error, right? So we have all these data points and these are the predicted one. Red color are basically showing the predicted values and the real values are these one, right? So basically the error is how much distance is there and you take the sum of them, right? So this way you can see the equation which we found was y is equal to 0.4x plus 2.4, and for this x value is 1. So what we will predict y value is this much, that is around 2.8, and the real value is 3 actually, right? Similarly for other, we see what we are predicting is 3.2. For other also we are seeing what we are predicting here, right? So this way we look for each one of them, right? And then we calculate the distance between them, and that is what we call as a error actually, right? So that much error is there, distance between the actual and the predicted value is known as the error, right? So here you see, so this is gradient search. How do we find, right? So it is showing, so if I will take you again from this way, so you can see it is trying different m and c values, and as it is doing here, you can see here it is coming, these were the data points. So it is showing what is the different value for m and c it is using, and when it reaches to some particular place, then the error would be minimum, right? So this is a particular red line which we are getting here. For this case, our error would be less, right? So you can use the method which we showed, or you can use the this is gradient search method actually, which we are not able to talk here, but because we have to do some code as well, so let's keep it quick ways. And what is the other measures we can use? So one is definitely you can use the mean squared error, right? How much the when you conduct the test, right? Initially, I told you one thing, that you are teaching to your machine, right? So machine learning techniques, that is why, or your software, you can say, it is learning from the data you gave the data, right? So let's say I teach them on the 70 data points, and then 30 data points I kept as a secret with me, so that I can test how much it has learned onto those 30 data points, right? And that is where R squared is. For those 30 data points, you may use whatever way you want to test them, or you want to look how exactly how good it works. You can use the R square value, or you can use the or you can use the mean square error, right? So there is a whole theory about the R squared. We will keep it very simple and short here. So R squared value is a statistical measure of how close the data are to the fitted regression line. So using R square, we will talk, or we will say how much close our data is to the fitted lines, right? So the line which we have chosen, how much close it is to that line. And we call it as the coefficient of determination, or the coefficient of multiple determination, right? So let's see, what does it mean R square, or how do we calculate it actually? So first of all, we normally, so we calculate the distances, that is actual minus mean, right? So we take all of these data points, so these are the predicted value yp, right? And then we have the actual values also for them. So how do we calculate it? So this is actually that if you take the distance, actual distance, right, and you subtract its value from the mean, and you are drawing it with the distance predicted minus mean, right? So what you are doing here, you have the actual distance, and so you are looking for actual distance from the mean value, right? So whatever value you got exactly, that okay, this is my data point, how much far away it is from the mean, right? So you do this thing, and you compare it with the, if you do the same thing with the predicted value, what you have predicted, how much it is away from the mean value, right? So the one which is predicted value and the one which is your real value. So your R square formula is what? Summation of yp minus y square. Actually, this is numerator, green color is your numerator completely. That is your yp minus y square, right? And your denominator is y minus y bar square. So what is this y bar? So y bar is same in both the cases because this is the mean. But what is this yp is the predicted. So for each of the value, you will see what is the predicted value, and then you will see here y is defining the real value. So you are comparing both of them, how much far away it is from the distances. Right. So let's talk about the R square here. So we have this formula. So for this we will calculate. So we know the mean for y, right? So we know the mean for y. So we do the, so this is actually a little bit overlapping is there, but we have the y value, real y value is there. We have predicted y values also here, right? Which I show you by using the equation y is equal to mx plus c, or mx plus c, and here you can see this is our y minus y bar whole square, and this is yp minus y bar whole square, right? So this way we do this formulation, and when we do the summation calculation further, then we find, in this case this is coming 5.2 and this is coming as 1.6. Yeah, Bharat is saying table data is overlapping. Yeah, data is little bit overlapping actually. So this PPT has been made actually especially for you guys only. So because we were thinking to do it for you guys, especially in which they were unable to test it actually. So because of which little bit issues are there, but it will not happen from tomorrow onwards. Okay, so this is the final values which you will get here, right? So summation 5.2 and this is 1.6. So you divide 1.6 by 5.2, and then you got your R square value. So what is the R square value? In this case, you are getting is 0.3, right? So now what would be the good R square value, right? So for a particular case here, in this case is R square is 0.3. In some cases it might be R square. So if we take the different data point, right? So if these are the data points here, right? So here, 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 which is far away from your this line, right? So what value you are getting? R square is equal to 0.3. But as you start bringing them closer to the line, then what you will find that R square value increases, which is 0.7, right? And as it becomes more closer, then R square value would become 0.9. Jaggi is asking how we get YP values. YP values, you remember, YP is nothing but the once you calculated this formula, right? That is Y is equal to mx plus C, right? So when you know the M value, when you know the C value, and you have already X value, then YP value you can calculate by writing mx plus C, right? While the real Y value is already given into the table, while YP is the one which you have predicted. Is it okay, Jackie? Okay, great. So you can see as the data point is coming more closer to the line, then it is R square value is increasing, right? So when it is exactly on the line, your R square value would be 1, right? So if we see here R square, if we see the data are far away from the correct value, so like here, 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 in this case R square value would be so much less, which is 0.02. So there are question, are low R square values always bad, or like mostly you will say yes it is, but that's not always the case. We can't talk currently here mathematics and the cases here, but currently you can keep it in your mind that the high value means good, low value bad, but not always, right? We will be discussing it when you will be going through the course. Now we don't have much time actually, so we have to do some coding as well, right? So we'll be doing some coding here. So this is the data set which I have taken, right? So this is we are going to do the coding for this data set. So what this data set is actually, this is a Boston housing data set. And so first of all, let me tell you what I have done. Few lines of code I have written here already. Like I am importing pandas as PD. So basically I am importing this library, pandas library, which is used to read the data set into a tabular form. Particular form is there, which is we call as such in Python as data frame, right? So it's pretty easy. You just import this library. And because this is my data set in the CSV file, which is bostonhousing.csv, I can read it by using the read underscore CSV function, right? So here I'm reading it, and then I'm just printing those top 5 rows, 0 to 0, 1, 2, 3, 4 rows here, right? So top 5 rows, if I want to print, I will use head function, df.head, right? Or if I want to, so if I write df, it will be telling me show more about these. So lots of values are there, right? So little huge data set, we want to see just minimum top 5 rows, we can see this thing. So what it is showing actually here, this is my first row, right? So this is what data set it is actually. It is a Boston housing. Let's say some real estate company come to you and they want you to make such a model so that they can predict what would be the prices of house, right? If some values are given to you, right, or if some properties are given to you of the house, then your model should tell what is the good price for this house, right, or what should be the expected price for this house. So they have collected the past data, and in the past data they route like this. This is the first row of data which they collected. 0th row means first row here, and they were showing that crime rate, CRIM is a crime rate, which is they were showing crime rate in which society this house is around 0.00632. Then this is another one. Let's say this is zone. So let's say how much green zone is there around, let's say 18. So these are different values are there. How old the society is or houses. So 65.2 years, let's say, right, and so on. So what is the normal tax being paid into this society, house tax and all is this much, and this is the median value of the house into this particular society and all, right? So this way we have lots of data set. So we want to do all here is to make a model so that whenever anybody give us these different value, we can predict what is going to be the correct value, right? So for this, let's say if you want to see this, so here we have the 14 columns, right? So if you want to see in what exactly these columns, so how many rows of data they have given us, 506 rows of data they have given us, where these are different values, crime values, zone, indus, and all. And this is our output variable actually, right? So this is initial variables, these are our input variable, we can say, or independent variable, we can say, right? And the median value is our dependent variable, or we can say y, right? So like you can think all these things are my x values, right? And this is my y value, right? Because this is what I want to predict. Okay, so now we are going to apply our technique, that would be machine learning. So for that we need to import few libraries, right? So first of all, what we are going to do, we will divide our data set into the two parts, right? So what is those two parts would be exactly? So these two parts would be our, we will take one, our training and testing. So you can think that, let's say this is the 506 houses data has been given to us, right? So what is the output value for them has been given. So what we will do, on 70% of this data, we will train our this linear regression algorithm, and on the 30% rest of the algorithm data, we will test them that what result it can give, right? So according to this, Jaggery is asking, according to this example, it will become n independent variables, correct? Here we have n independent variables, right? Or actually 13 independent variables, we can say. We have total 14 variables, in which this is our output variable or dependent variable, and the rest 13 variables are our independent variable or input variable, right? So first of all, we will take from sklearn dot. So there are, so first of all, what we are going to do, we are going to divide our data set into training and testing side. So training means on which my machine learning algorithm uh, will try to learn, right? Will try to learn, right? It is equivalent, because this is supervised learning, it is equivalent that 70 questions we are showing with their solution, and for the rest 30 questions we will do the testing, that how it can generate the result, right? So this is a library which is within sklearn. We have this model selection, in which we have this function train test split, right? So we imported this thing, and it will divide our data set into two parts. So before applying this thing, what I am going to do, I am going to tell what is my y value in this. So y value is my median value. So I will write y is nothing but in my data frame, if I take median value is my y, right? So basically I have taken y here separately, right? Similarly, I will take x. The rest thing I will take here. So I will write df dot drop, and here I tell which column I want to remove. So I do not want to have the median value, and because this is a column I want to remove, so I will write x is equal to 1, right? So if I show you now what is x dot head, so the top 5 rows we can see here, you can see median value is not coming because I have removed from here and I am storing here, right? So I'm keeping all my output variables dependent variables, one dependent variable only here we have into y, and the independent variable I am keeping into the x, right? So now what we will do here, we will keep train x, test x, and train y, test y, right? So there seems to be a question I will take in a moment. Train test split function I will call, and I will tell what is my x, what is my y, and as well as I will tell what is the test size I am looking for, right? So let's say if I am saying 33% should be my test set, then I will say test size is equal to 0.33. So here we divide our data set. So Jaggery is asking what is the use of axis. So as I told that if I write axis is equal to 1, it understands that I want to remove the column. If I do not write axis is equal to 1, or I write axis is equal to 0, it will think that I want to remove the row, right? So by writing the axis value, we are telling whether it's a column or row. Okay, is it clear? I hope so. Now, so Bharat is saying, can you explain last line again? Which line you are saying? Line number 11 or 9? Which one, Bharat? Bharat, can you just write completely again? Do you mean line number 9 or 11? Line number 11. Okay. Yeah, I am coming to that. I didn't tell it completely actually till now. So x and y, I told you already what is my x, right? So in x, my all independent variable, right? And in y, my dependent variable, or we can say output variable. By writing here 0.33, I am saying I want to divide my data set into two parts. One is training, one is testing. So training on which I will give the solution as well. It is equivalent that here I am telling. So here I have this book in which this is a book of questions and this is the book of solution. So what I am doing using this particular function is I am dividing my this book 100 questions were there, let's say earlier. I'm dividing 77 questions I will take for teaching, right? And when I teach those 77 questions, I will show you the solution as well. While the 33 questions I will keep intact with me, and I will not show you the solution to them. But for conducting your test, I will give you the questions, those 33 questions, and then I will match how good result you are giving, right? That is what it is written. It is returning us four things. This train X is my training questions. This train Y is my training solution. For these training question, these are my solution. And for these testing question, these are test X is my testing question. For them, I have these as a solution. That is my test Y. So if we see also, first of all, let me show you how many values are there. So in train X, there are 339 rows or data points and 13 columns, right? And if I show you about train Y dot shape, then what do you see? Only 339 rows are there. So when it is nothing, it means one column. So it means this is exactly the result for all these questions. Similarly, if I show you test X dot shape, then it is having 13 columns again, right? Because all the independent variable would be, but 167 questions it has, right? And similarly, if we look test Y dot shape, then it is having solution correspondence to these questions, right? I will show you also few of the top values. Like if I write train X dot head, so that you guys can see top 5 rows. These are top 5 rows, right? And you can see randomly it has been chosen. First row becomes 60th row, then randomly it chosen 77th row, 170 row. So randomly it has chosen 339 questions, right? Out of all the 506 questions, something like we had, right? Similarly, these are so corresponding to them. We have train Y, right? These are the top 5 solution. You see this is 23.45. So this is their label. 60th question, 16th here, 77, 77, so that you can match it with each other. And correspondence to this particular row of data or input variable, this is my output value, right? Similarly, we have in the test. So what we are going to do now, we are going to teach it, right? Using our these training sets. So for that, we need to import the linear regression model. So how we can import it? So we have again this library from sklearn dot, into this we have a linear model family, right? So this, from this we are going to import the linear regression, right? So this is a particular class we have imported. Now we can create its object. We create its object by just writing lm is equal to linear regression. Its object is ready. Now we can execute our model. So we write lm dot fit. So basically fitting means I'm saying learn, right? How to learn? I will give it the questions. That these are the questions, that is my train X, and these are my solutions. So I'm giving it questions as well as their corresponding solutions, so that it can learn from it or can find out the solution. So it has learned it now, right? And now we can test it. So how we will test it? Basically, we will do the prediction, right? So how do we predict the values? So I want to predict now what output it is giving. So I will use predict function. In this, I will pass only test x. Now you can see I'm just passing the test x, right? So that I can see what it is predicting. And let's say yp is my predicted output. So lm dot predict, we can say here is the one which here we are predicting. Vishy is asking, can you please explain 16 and 17? Yeah, I will go again to this line, right? 16 line. So we had our data set initially, right? In the df, we had all the data points, right? So if I show df dot in head, then it was having rows 0, 1, 2, 3, 4, right? But when I call this particular function train test split, so randomly it takes 339 value and put it into train x, and whatever 339 value it takes into train x correspondence to them, it takes 339 output values into train y. Similarly, it takes test x randomly 167 values, and correspondence to them output values were written here, right? So this train x dot head is showing because it has chosen randomly. So first row it chosen randomly was 16th, next row it chosen randomly was 77, next row it chosen was the 170, right? So this is the way my data set is. Train x, that is my questions. You can say if I am talking about question and solution. Train y is my output values correspondence to them. So within the train x, these are 339 questions I have, or you can say 339 data points or data observations are there, right? You remember from the slide, we were having the observations, right? So like these are the observations, right? So these are the observations are there. This is nothing but, so x value is in my here, right? So these are defining my x value because I have more than one dimension, one variable, right? And y value is coming into it, right? So I just showing here top 5 rows. When I call with the data frame dot head function, it shows me top 5 rows only, right? Otherwise, if I do not write it, it will show me the whole thing. It will take a lot of space, right? So if you see here, it is showing me all nearly all the data points, right? Like here it write dot dot dot, it means there are a lot of in between also there, right? But I do not want to take it space on my screen, so I just show you the top 5 rows. Similarly, if I write train y here, it will be showing me a lot of values like this, right? But I want to take only top 5, so I write here. So why I am doing here head and y here 0 to 5, because this is a data frame, this is a series, right? So there is little different, the both things are handled in little different way, right? So whenever you have so I will not go into that much, better we keep it short. You can just say this is a different data type, this is a different data type, and in both the data type for accessing them is little different way. Okay, is it clear? Okay, great. So let's go ahead. Now I am going to predict the value, right? So this is model has learned it, right? It has learned. Now I am going to predict the values. So how I will predict the value, I will write yp is equal to lm dot predict. So this is a function for predicting the value. So if I execute here, it has predicted the output value. So what is the output value? Predicted output values are these. 5.8 is the first one, 30.70 is the next one, right? And if I talk about the correct value is in my test x, sorry, test y, right? These are the correct value, that is 10.5 and on so on, right? So if you want to compare them as well, we can compare it in different ways. We can compare it, so we can show them together as well. Let's say, let me make one data frame. Let's say I call it op data frame is equal to pd dot data frame, right? So we make a dictionary, let's say real value, and real value is in our test y, and then we give the another one which is predicted value, and that is into our yp, right? So if I execute it, output data frame, if I show you, So you can see this is the real value 10.5, right? It is showing also row number was 386. Let's leave it. Look these two values, right? Its real value is 10.5, but the one which we are predicting here is 5.8. Here the real value is 23.0 and the one which you are predicting is 30.7. Here the real value is 70.1 and the predicted value is 70.36. So very much close here you guys can see 18.2, predicted one is 18.44. Right, so this way you guys can see 22.8, 24. So here you can see less error actually, right? So in reality this might not be following exactly the straight line, right? So that is why we will have always error. Sometimes it is good to use non-linear model, right? So this is we use linear regression here, but some places it is good to use the non-linear model, right? And let's say if you want to calculate the let's say if you want to know exactly, right? So we talked about y is equal to mx plus c equation, right? Or if we have more than one variable, so it is actually y is equal to m1 x1 plus m2 x2 plus m so on, right? So if we have 13 variables, so it would be m13 x13 plus c, right? So this would be the thing here, right? So let's say you want to know what is my m1, m2 and c value, how you can get it. So if we write lm dot, right, so if we write coefficient underscore, then it is showing me these coefficients. So this is first, second, third, fourth, right? So you can see because we have 13 coefficients, so it is showing 13 values, 13 variables are there, right? m1 to m13. So this is the first coefficient value, this is the second coefficient value, third coefficient, fourth, and so on. So we have 13 coefficients, we get all the values. Similarly, you might be interested in finding what is the this c value, then you can write lm dot intercept, right? So the c value is 40.15. So that become your equation here, right? So you can see this way how easily you can apply your linear regression technique, right? And there are a lot of things you can do here, like lm dot. I will just keep it currently, like you can choose even score, but let me not do this thing. Let me show you one more thing, that is mean squared error. Let's say if you want to calculate the mean squared error, how you can do is from sklearn dot matrix, you import mean squared error, right? So this is a function, you call this function, to this function you tell what is the predicted value you have and what is the real value you have, test y, right? So it is giving mean square error is coming 21.37, right? So it is little bigger in this case actually, right? So sometimes linear model is not the good model actually. You might need to think that if shall I use some polynomial regression in those cases, right? But this is how you can apply your model. Okay, I hope so it is clear to all of you guys. Any question, any doubt do you guys have? If you guys have any question, let me know. Will you teach sklearn library? Yes. During the course, it is being taught, right? And here in this case, actually, just for the basic part. So like maybe like tomorrow and day after tomorrow, also we have the going on sessions are there. And whenever sometime few sessions get finished little earlier. So during that session, I will be telling you also about these library exactly how you can understand these things, right? Exactly what these are doing, what is the role of each of these, what is function, what is class, and all. So Kadri is saying, thanks, I appreciate your class. Thank you for appreciating Kadri Hassan. Jagri is saying, why is requirement to learn math for ML when everything is predefined? See, lot of things, yes, there is no need. In many cases, there is no need. But if you are going to do little bit research work with these stuff, machine learning, then for that you need to have the mathematics. But yes, for doing the application part, it is perfectly fine. You doesn't need to go into the so much depth of the mathematics, or even mid level of mathematics is also not needed. So webinar is asking, are these Python function? Yes, these are the Python function actually. Like mean square error is a function, right? And that belongs to this within the sklearn. We have this module which is matrix, within which this particular function exists. So that is what we have imported and we use it. Similarly, earlier also exactly the same thing, right? So whatever we used here, like within the sklearn, this linear regression is a class actually, and its object we have created its object. Right, Bhaskar is saying thank you. Yeah, welcome, Bhaskar. And Bharat is saying it's nice. I learned new today. Thank you, sir. Does we have certificate after this course? During these free classes, I think the certificate will not be given most probably. I'm not sure about that. But yeah, if you enroll for their courses, right here we'll be doing few free sessions, but there are a lot to learn still. And if you enroll for their courses, definitely then you will have the certificate definitely for that. And you need to submit the assignments for that. You need to do the projects for that, submit the projects they will ask you, and after that you get the certificates. Okay, webinar registrant saying thanks for helping. Yes, you're welcome. Jagri is saying what is best certification for data science. So they are providing in yesterday's slide. Have you attended the yesterday's session, Jagri? Okay, so I will recommend you please go to the yesterday's session. It was who is a data scientist, right? So you will get it on YouTube. So you go that, you watch that session. It was taken by me, and I discussed about the certification as well and what would be taught exactly in which certification completely exactly, right? Or if you do not want to go initial part, maybe you do not want to see who is data scientist and all those stuff, you can go to the last 10-15 minutes in the webinar, that particular YouTube video, and then you can get it. Okay, I have discussed this in there. Okay, yeah, and can you tell email ID where we can email for getting the PPT? You go to their website, you will find some support email ID, right? Or you will get some contact number there. You can talk to them, and then they will tell you. And you can come to tomorrow class. I will discuss with them as well. So when you are coming to tomorrow's class, I can ask them as well, like in today, that what is the process or how they can get the PPT if they are interested, right? So I will share it in the tomorrow class as well. Okay, okay, Bharat. Check. Okay, fine. Thank you, sir. Yeah, you're welcome. Webinar is turned. Okay. Okay, great. Guys, thank you very much for listening with so much patience and appreciating the lecture session. I hope you learned something new. You are enjoying all this stuff. So let me finish the session then. Thank you very much, guys. See you in tomorrow class. Happy learning till then. Bye bye. Take care.